Hi everyone, my name is Jing. I'm a PhD student from the HCI lab at the University of Melbourne, Australia. I work on conversation agents and smart speakers. Today, I will present our work titled Understanding How to Administer Voice Surveys Through Smart Speakers. As HCI or CSCW researchers, I believe many of you have used a survey as a method to collect user data. There are plenty of popular survey platforms, such as Qualtrics and Google Form. You may also be familiar with voice-based surveys sent to you through robocalls. See, surveys can be deployed on various platforms. Since I'm a smart speaker person, I think smart speakers can be a new modality for survey administrations. However, smart speakers are not the same as a GUI interface, and may not even be that similar to a phone interface, as we want to collect reliable and valid user data. It is important to understand what types of questions can be implemented through smart speakers and the quality of those voice surveys. In our study, we designed a within-subject experiment. We want to compare voice surveys with the commonly used web surveys. We want to test 5 common question types: open-ended questions that are implemented as demographic questions, binary, yes and no questions, 5-point Likert scale questions answered with numbers from 1 to 5, 5-point Likert scale questions answered with words such as agree and disagree, and 7-point Likert scale questions answered with numbers from 1 to 7. Except for open-ended ones, for each of the other 4 types, we use a well-established survey and split it into 2 halves. Then we implement one half to be voice survey and the other half to be web survey. This way, participants can answer similar but different questions on both modalities. Since most commonly used surveys have great internal consistency, we can easily evaluate the voice survey by comparing its responses to web responses. All participants were asked to answer both voice and web surveys in one session. We also designed a 3-question survey that measures the question difficulty for participants to answer on their phone after completing each survey, and a modality evaluation form. At the end of each session, participants will rate their preference for survey modalities in various in-home activity scenarios. Lastly, as you can see from the figure, we actually asked participants to complete the identical session twice, with 1 week apart, so that we can mitigate the novelty effect and understand the test and retest reliability of voice surveys in comparison to web surveys. Before diving into the response quality, let's take a look at the time cost for voice and web surveys. From the figure, it is quite clear to see that voice surveys can take longer to answer than web surveys. In particular, for the 5-point and 7-point Likert scale surveys, it is interesting to see that it takes around twice the time to finish voice surveys than web surveys. When conducting surveys, it is important to reduce the respondent burden. Hence, we think if future researchers want to use smart speakers and the web together to collect survey responses, it may be necessary to reduce the number of questions for speakers, maybe just do half with voice. In terms of response reliability, we find that the voice responses have a high correlation with web responses, which means that smart speakers can collect similar responses to web surveys. In our study design, half participants were exposed to web first, and the other half used smart speakers first. And we find that the web voice group has great response agreements, whereas the voice web group shows improvement in the second session. In other words, we observe the learning effect of voice surveys. Comparing the responses from 2 sessions, the binary questions actually have better test-retest reliability when deployed on smart speakers. We also measure the response quality for closed-ended questions. Voice and web have similar response quality. On the other hand, it is quite surprising to find that participants provided significantly shorter responses to 3 open-ended questions using voice. Prior to our study, we assumed that smart speakers may be better for questions that accept free-form answers, as speaking is faster than typing. However, smart speakers nowadays have a 5 to 8 second window for user input. Compounded with the speech recognition limitation, we find that participants tended to give shorter answers to smart speakers. Within voice surveys, we also find pros and cons of different scales. For example, it is surprising to find that most participants considered open-ended questions difficult to answer. One participant mentioned that he simply imagined a drop-down menu in his head and chose from that imagined menu. Comparing the 5-point and 7-point, many participants liked the 5-point scale as it was more familiar to them, whereas the 7-point was too fine-grained and hard to visualize. Also, the number scale is easy to visualize and think of than the word scale. Lastly, many people enjoy speaking the yes-no answer, but pointed out that strongly agree or strongly disagree could be hard to speak, as it is rare to have an extreme stance in daily conversation. The user preference for survey modality under different scenarios is shown in this figure. Of course, if you are doing push-ups, it is unlikely to use a computer. Visually speaking, we can see that voice surveys are voted more than the web surveys, despite the difficulty of using voice surveys caused by speech recognition and some delays. Many people enjoy the multitasking and hands-free nature of voice. Particularly, some participants suggested that using voice to answer questions helps them to separate the survey and their work. Drawing on our results, we provide our recommendation for voice survey question types. We think both the binary scale and the 5-point numerical scale can work well on smart speakers. We also suggest researchers provide a training session to help users learn the voice survey system, and maybe consider implementing fewer questions on smart speakers than they would normally do using a web platform. Lastly, the limitation of smart speakers, such as speech recognition rate, should be considered. Researchers may implement fewer open-ended questions, as answers to those open-ended questions may include incorrect transcriptions that require manual corrections later. That's all. I hope you enjoy this presentation and know a bit more about smart speaker surveys. If you have any questions, you can refer to our paper, or contact me via email, or even add me on Twitter. Thank you.